Hello students, today we will study a very important topic in chemistry, laws of chemical combination and gas laws. These laws explain how elements combine to form compounds and how gases behave under various conditions. Let's begin with the laws of chemical combination. Law of conservation of mass. This law was proposed by Antoine Lavoisier in the year 1750. It states, during any physical or chemical change, the total mass of products is equal to the total mass of reactants. Or you can say, matter can neither be created nor destroyed during a chemical change. Let me give you an example. 12 grams of carbon react with 32 grams of oxygen to form 44 grams of carbon dioxide.
Ma'am, may I ask a question?
Yes, go ahead.
Ma'am, who proved this law?
Good question. It was demonstrated by Landolt through a series of experiments. Now, the modern view adds a twist. According to Einstein's equation, E equals mc square, mass can convert into energy. But in ordinary chemical reactions, the energy change is too small to measure any change in mass. So, the law holds true in all normal chemical changes. Law of constant composition. This law was given by Joseph Proust. It says, a pure compound always contains the same elements in the same ratio by mass, regardless of its source. For example, water collected from river, rain, or well will always have hydrogen and oxygen in the mass ratio 2:16, that is, 1:8. Law of multiple proportions. This law was proposed by John Dalton. It states, if two elements combine to form more than one compound, the mass of one element that combines with a fixed mass of the other is in the ratio of small whole numbers. Let me give an example. In ammonia, NH3, 14 grams of nitrogen combine with 3 grams of hydrogen. In hydrazine, N2H4, 14 grams of nitrogen combine with 2 grams of hydrogen. The ratio of 3:2 is a simple whole number ratio. Law of reciprocal proportions. This law was given by Victor in the year 1792. It states, if two elements combine separately with a third element, then they will also combine with each other in a simple or simple multiple ratio. Let's understand this with an example. Carbon and sulfur both combine with oxygen. Carbon with oxygen, mass ratio is 12:32 or 3:8. Sulfur with oxygen, 32:32. Now in carbon disulfide, CS2, carbon combines with sulfur in the ratio 12:64 or 3:16. So, the ratios 3:8 and 3:16 are related as 1:2, hence, the law is verified. Gay-Lussac's law of combining volumes. This law says, gases combine in simple whole number volume ratios under the same conditions of temperature and pressure. For example, 1 volume of hydrogen reacts with 1 volume of chlorine to form 2 volumes of hydrogen chloride. So, the volume ratio is 1:1:2.
Ma'am, may I ask a question?
Yes, please.
Do these volume ratios work at any temperature?
Great question. These ratios only hold if the temperature and pressure are the same for all gases involved. Now let's move to gas laws. Boyle's law. At constant temperature, pressure is inversely proportional to volume. We write this as P is proportional to 1 by V or PV equals constant. So, P1V1 equals P2V2. Charles' law. At constant pressure, volume is directly proportional to absolute temperature. V is proportional to T, or V by T equals constant. So, V1 by T1 equals V2 by T2. Application example, when a hydrogen balloon is heated, it bursts because the gas expands. Also, The chapati puffs up due to gas expansion inside. Gay-Lussac's law. At constant volume, pressure is directly proportional to temperature. P is proportional to T, or P by T equals constant. So, P1 by T1 equals P2 by T2. Avogadro's law. Equal volumes of gases at the same temperature and pressure contain equal number of molecules. That is, volume is proportional to number of moles. So, we by N equals constant. Dalton's law of partial pressures. When multiple non-reacting gases are present in a container, the total pressure is the sum of the partial pressures of each gas. That is, P equals P1 plus P2 plus P3 and so on. Ideal gas and ideal gas equation. An ideal gas is a hypothetical gas that follows all gas laws perfectly under all conditions. It obeys Boyle's law, Charles' law, and Avogadro's law. Ideal gas equation is PV equals nRT, where P is pressure, V is volume, N is number of moles, R is gas constant, and T is temperature in Kelvin. Alternate forms include PV equals W by M into RT and PM equals dRT, where W is mass, M is molar mass, and D is density. Important facts: gas constant R has different values depending on units 0.08 to 1 liter atmosphere per mole per Kelvin, 8.314 joules per mole per Kelvin at higher temperature. Kinetic energy of gas molecules increases, leading to more pressure. Standard temperature and pressure, called STP, is 273.15 Kelvin and 1 bar. Volume of 1 mole of gas at STP is approximately 22.4 liters.
Ma'am, may I ask one last question?
Yes, go ahead.
Do real gases follow these laws exactly?
Very good question. Real gases behave like ideal gases only under low pressure and high temperature. Hydrogen, oxygen, and nitrogen show near ideal behavior under such conditions. So students, these were the laws of chemical combination and gas laws. Revise the formulas, understand the logic, and you'll never forget them. That's all for today. Jai Hind.